know much about algebra. Don't know what a sliding rule is for. But I do know one and one is two. This one could be with you. What a wonderful world this would be.
Welcome to Mr. K's 30 Minutes of Math. I hope everybody is doing well this Tuesday afternoon. I know it was a little cloudy this morning, but it's supposed to get sunny this afternoon, so I hope you get some time outside. And I'm gonna turn off the video so we can dive in on today's work. So let's begin with our riddle of the day. As you recall, we had cats and bunnies, and we had some chasing going on. And the question was, if 3 cats can catch 3 bunnies in 3 minutes, how long will it take 100 cats to catch 100 bunnies? So, interesting question to think about. I was curious if anybody had an answer. I see Delilah writes in 3 minutes. Anybody else? Anybody else have thoughts about what the answer might be? I'll give folks just a second to go ahead and write in if you have any thoughts. If you didn't get a chance to work on it, no problem. 3 cats catch 3 bunnies in 3 minutes. How long will it take 100 cats to catch 100 bunnies? All right, I see we have an answer of 100 minutes. All right, we have 300 minutes. Ooh, lots of good answers to debate. All right, ready for our drum roll. Here we go. 3 minutes it is. 3 minutes it is. Let me try to explain that one. All right, if we have 3 cats and they can catch 3 bunnies in 3 minutes, let's think about what's happening there. So we have 1 cat, let's just call it C, running around to chase a bunny. And there's another cat running around to chase a bunny, and another cat running around to chase a bunny. All together, it takes 3 minutes for them to catch the bunny. So if you think about it, each cat needs 3 minutes to catch one of the bunnies. It's all happening at the same time, but if it happens over 3 minutes, each cat needs 3 minutes to catch a bunny. So that means 1 cat needs 3 minutes to catch a bunny. 2 cats need 3 minutes to catch 2 bunnies. 3 cats need 3 minutes to catch 3 bunnies. So 100 cats would still need 3 minutes to catch 100 bunnies. All right, well done. I know that was a tricky one. Let's dive into our homework from last night. If you were able to capture it, that is fantastic. And if not, that is okay. We're going to go over it together. All right, so starting with our fractional units, we have fourths, 24ths, 12ths, and eighths. All right, so let's decompose everything into 24ths. So I'm going to start over here. 5/4. We can decompose that by multiplying our fourths by 6. So that is going to give us 30 24ths. All right. 7 24ths we don't need to do because it's already in 24ths. 6 12ths, we can decompose those into 24ths by multiplying by 2. So that's 12 24ths. And then 1/8, we can decompose the eighths into 24ths by multiplying by 3, which would give us 3 24ths. Okay, so let's rewrite this. We have 30 24ths plus 7 24ths minus 12 24ths minus 3 24ths. Okay, 30 and 7 Well, that's going to give us 37/24. Whoops, that wasn't quite right. Let me fix that. Then we're going to subtract 12 of them. 37 minus 12 is going to give us 25/24. And then we're going to subtract 3 more, which is going to give us 22/24. There you go. That is your answer. We can simplify that by composing our 24ths into a larger fractional unit. So for example, we could do 22/24. And remember, to compose into a larger fractional unit, we'll divide, which would give us 11/12. That is also a wonderful answer. Good job, everybody. Fantastic, fantastic work. All right, let's go to our first problem of the day. Go ahead and take a minute to work on this one. Read it, draw it, and then work it. Do the calculations. Go ahead, take a minute. Well, that is a good place to stop the music and go ahead and take a look at this one. So let's read it together first. Olivia is an athlete, and during training this morning, she ran 3 laps. I've drawn our laps at the bottom. Think of them as big loops around a track. It took her 5/6 of a minute to finish the first lap. All right, whoops. 5/6 of a minute for the first lap. The second lap took her 1/12 more minutes than the first lap. So the second lap is 1/12 more than the first lap. Okay. And the third lap took 1/10 less than the second lap. Oh boy. So here's our second lap, remember. And the third one took 1/10 less. So we're going to subtract 1/10. Whew! How much time did it take her to finish the third lap? All right, the third lap. So remember, the first lap was 5/6. The second lap was 1/12 more minutes than the first. So 1/12 plus 5/6. And then the third lap was 1/10 less than the second. This is the second, which I repeated right here. And then we want 1/10 less, so we're going to subtract. Okay, so here is what we need to work on. 1/12 plus 5/6 minus 1/10. Let me clear off some space so we can do our work. All right, so we have 12, whoa, sorry about that. We have 12ths, 6ths, and 10ths. And so the question is, what should we use as our fractional unit to do this problem? So I'm going to go with 60ths. So 1/12 equals how many 60ths? Well, we can decompose our 12ths into 60ths by multiplying by 5. Okay. Then 5/6 equals how many 60ths? We can decompose our 6ths into 60ths by multiplying by 10. So there's 50 sixtieths. And then 1/10 we can decompose into sixtieths by multiplying by 6, which gives us 6 sixtieths. Okay, so let's rewrite this now. 5 sixtieths plus 50 sixtieths minus 6 sixtieths. All right, 5 and 50 will give us 55 sixtieths. And then if we subtract 6 of those sixtieths, we're left with 49 sixtieths of a minute. 49 sixtieths of a minute. 49 sixtieths of a minute is another way to say 49 seconds. 49 seconds. That is how long it took her to do the third lap. I know that was a tricky one, lots to think about. Let's try one more before we get to our joke of the day. Here you go. Okay, welcome back, everybody. Let's take a look at this one. Let's read it first. Kyle is a basketball player. His bottle was full at the beginning of the game. At the end of the first quarter, he drank 5/7 of the bottle. So I'm going to draw, whoop, that is not very helpful. I'm going to draw a bottle. I'll just draw it as like a tall cup. And at the end of the first quarter, he drank 5/7. So 5/7 gone after the first quarter. A coach filled up his bottle for him during the second quarter. All right, at the end of the second quarter, he drank some more water and only left 2/5 of the water in the bottle. So he had 2/5. All right, so let's kind of do it like this. 1, 2, 3, 4, 5. Okay, so I have fifths. So at the end of the second quarter, he drank some more water and left only 2/5 in the bottle. So he had this and this left. So he drank all of this. And in the first quarter, let's do sevenths. 2, 3, 4, 5, 6, sevenths. Okay. And he had 5/7 were gone, which means he had 2/7 left. Okay. And this one, he had 3/5 gone. All right. How much water did he drink during the first half of the game? Well, how much did he drink during the first quarter? 5/7. How much did he drink in the second quarter? 3/5, because we know 2/5 was left over. So how much did he drink altogether? Well, he had 5/7 of his bottle plus 3/5 of his bottle. And we're going to decompose these 7ths and 5ths into 35ths. So 5/7. We're going to multiply by 5 to get 35ths. Okay, 25 35ths. And then 3/5 to get 35ths. Sorry, it's a little tight there. We're going to multiply by 7. So that would be 21 35ths. So 25 35ths plus 21 35ths would be 46 35ths. 46 35ths, which if we did our number bonds, let's make some space to do our number bonds. Let's get rid of all this. All right, we would have 35 35ths, that's one whole, and then we'd have 11 35ths left over. So we would have one whole bottle and 11 35ths of a bottle. Wow, we had a few folks chime in with the right answer. Well done, well done. All right, well done, very proud of you guys. All right, let's move on to our joke of the day. Here it is. Why was the dictator so good at geometry? All right. Whoops, we had more Jeopardy than I expected. All right, we have a few answers. A+ in math. He went to school. His subjects were in good shape. That one deserves. Oh boy. Excuse me while I delete somebody from our chat. I am deeply sorry for that very offensive language, and I have deleted that individual. And again, anybody who is on the chat, the only reason you should be writing in is to answer the math problems. And if you write anything else other than related to the math, I will remove you. Again, that is unacceptable. All right, I'm going to go back to our joke. I'm so sorry again for that terrible, offensive comment that was made, but we have now removed that individual from our conversation. Why was the dictator so good at geometry? Well, he was the supreme ruler. The supreme ruler. You guys, I know, are big fans of the ruler. He was the supreme ruler. All right, let's move on to some of our geometry work that we've been doing as part of our math jokes. And I would like you to go ahead and tell me, and this time I'm going to do 4 points. What are the coordinates for A, B, C, and D? Go ahead and work on that and take a minute to do that. Okay, welcome back. Let's see how we did. Let's start with A, and let's use yellow. We always start at the origin, and we're gonna do our X coordinate first. So 1, 2, 3 to the left. So that's a -3, and then 1 up. So that's +1, so that's A. B, 1, 2, 3 to the right, +3, and 1 up, so that's +1. C, let's use green for that. 1, 2, 3, 4 to the left, and 1, 2, 3 down, so -4 and then -3. And then D, 1, 2 to the right, and then 1, 2, 3 down, -3. A little bit tricky to track all of those, but it looks like most folks got it. Well done. Impressive work. Impressive work. Well done. Well done. All right. Now what I'd like you to do is tell me let's get our ruler back. All right. What is the slope of the line that connects A and C? So that side of our parallelogram, the green one. And also tell me what is the slope of the line that connects B and D? And that will be our yellow line. So go ahead and figure out the slope for the green line and the yellow line. Go ahead and take a second to do both of those. Okay, welcome back. Let's take a look at this. Let's start with the green line. What is our rise? 1, 2, 3, 4. And what is our run? 1. So this line has a slope of 4 over 1. And then we could do our yellow line. Let's see what the rise is. 1, 2, 3, 4. And the run is 1. So if you notice, they have the same slopes. So here's my question. We have a special name for two lines that have the same slope. What do you call those lines? Two lines that have the same slope, like the green line and the yellow line. What do you call those? They have the same slope, the green one and the yellow one. Anyone have any ideas? What would you call those two lines? There's a special name, and I'll give you a hint. It starts with a P-A-R. Anyone have any idea what those two lines would be called? And if not, that is no problem. Well, we call those lines parallel. Parallel, because they are always at the same slope, which means they're always going to be the same distance apart. All right, let's get back to our fractions. I'm going to skip that one over, and let's just do this one before we get to our homework and our riddle for the day. Here you go. Okay, welcome back, everybody. Just one more reminder, if you are using the chat for anything other than the math, I'm going to have to remove you from the webinar. So please keep the conversation limited to just the math. All right, we have some folks wrote in 59/60ths of a kilometer in 1 minute. Let's check it out. Emma is a professional cyclist. For the past year, she has been practicing to ride as far as she can in a minute. At the beginning of the year, her personal record was 5/6 of a kilometer in 1 minute. After 6 months, she improved her record by 1/15 of a kilometer. So if she improved, she got faster, which means now she can do 5/6 plus 1/15 of a kilometer in 1 minute. And then after a year, she further improved her record by 1/12 of a kilometer. So now she can do 5/6 of a kilometer and 1/15 and 1/12 in 1 minute. All right, let's convert these fractions by decomposing into a common fractional unit. And I think 60ths would be great. And given that our time is short, I am going to do the shortcut. This would be 50/60ths. This would be 4/60ths. And this would be 5/60ths. We add it up and we get 59/60ths. And I see a number of you wrote that in. Well done, well done. All right, this is tonight's homework. I got a little bit of feedback that we need to spend a little bit more time to give folks an opportunity to take a picture or take a screenshot. So I'm going to read this, give you a chance to do that. A football team was training for 4 hours. During the first hour, they practiced for 5/8 of an hour. During the second hour, they practiced for 2/3 of an hour. During the last 2 hours, they first practiced for 3/5 of an hour, took a 1/2 hour break, and then practiced the rest of the time. How much time did they spend practicing in total? All right, hopefully you've been able to take a screenshot or take a picture with your phone or jot it down. Go ahead and work on that one tonight. And let's wrap up with our riddle of the day. And again, you might want to take a screenshot or a picture of this one. The question is, what is the weight of each animal? 2 little bears equals 120 kilograms. I think that's a bunny. A bunny and a bear equals 70 kilograms. And then a bunny and a fox, sorry, a bear and a fox and a bunny equal 90 kilograms. So go ahead, take a picture, take a screenshot, or write it down. And the question is, what does each individual animal weigh? All right, everybody, good to see you. I hope you have a great afternoon. I see the sun coming out, which is very exciting. And we will be back tomorrow. Have a great afternoon. Bye, everybody.